Hello everyone, I'm Joshua Samuel, a Solutions Architect at AWS. Today, I'm going to give you a choose-your-own-adventure story that I've seen repeated a number of times across different enterprises. I'm going to introduce you to some of the bigger choices that you must make when implementing EKS at scale. So, what will this session look like? I'll start with a brief overview of containers on AWS. I'll then cover the topic of one-way door decisions, the decisions we care most about. Next, we'll dive into the key decisions that you will be required to make when designing and building EKS for your enterprise. From the number of clusters to create, through storage, networking, security, and orchestration. I will then share with you about one customer that I've recently been on this journey with, NAB, and how it will transform their business. To close, I'll then give you some resources to help you on your own journey. So, why are you here today? Organisations are looking to become more agile so they can innovate and respond to change faster. This requires a different kind of application than what was common years ago. Applications now need to rapidly evolve and to scale quickly to potentially millions of users, have global availability, and manage petabytes, if not exabytes, of data and respond in milliseconds. Companies want their deployments of their applications to be low risk and low friction, rather than large monolithic upgrades with significant blast radius. To meet these demands, companies need to reconsider the foundation on which these apps are built and run. This has led to the rapid adoption of containers, a key technology that provides new levels of agility for organisations, both in terms of development and deployment. AWS Container Services make it easier to manage your underlying container infrastructure, whether on-premises or in the cloud, so you can focus on innovation and your business needs. Today, we are going to focus on EKS. This is your first big decision, a one-way door. You have requirements that pushed you towards Kubernetes. Perhaps you have Helm charts supplied by software vendors, or you require the power of open policy agent policies for your security posture. Or you may have existing Kubernetes skills in your team and you want to make use of those skills. With Kubernetes growth in container orchestration in recent years, you and your team want Amazon EKS. However the decision was made at your organisation, you have now been given the task of working out how to build it in a way that works for your environment. Getting consensus on how to build your cluster can be challenging. Many areas of your enterprise will have opinions on what is needed, and some areas may have hard requirements. Understanding which of these decisions, requirements, and opinions are important, and which ones can be deferred until later, is an important starting point. One tool we use at Amazon to assist us in making high-quality, high-velocity decisions is a mental model we call one-way and two-way doors. A one-way door decision is one that has significant or complex to reverse consequences, whereas a two-way door decision is one that has limited and reversible consequences. Applying this ethos to building out container orchestration leads us to workshop the complex and hard to reverse decisions and leave the implementation squad to worry about implementation details for the two-way door decisions. This helps us cut through the large pile of opinions and options and focus on the parts that are absolutely required. So, who do we need to get consensus from with these bigger decisions? You may not have all the functions I mention here separated out, but what I want you to consider is who in your organisation will be affected by what you are building. Typically, I would include representatives of cloud or enterprise architecture, platform teams, security operations and security architecture, representatives of a couple of important workloads for the platform, a cloud platform executive or other executive project sponsor, and let's not forget FinOps. You want all of these teams to be actively supportive of your project and the decisions made. Getting their input before you start building is one step towards this. Time to bring everyone into the same room at the same time and workshop only the biggest issues that need everyone to agree on a direction, the one-way doors. I like workshops to start with the vision of what your organisation wants to achieve, both the vision of what you want from a Kubernetes environment as well as the environment as a whole, including CI, CD, and business or team efficiency goals. Executive endorsement of that vision can ensure broader cooperation from disparate representatives. Next up, let's level set on your priorities and how they compete. As a team, you may debate whether deployment speed is more important than cost, or whether security is job 0 or job -1. Your priorities should be small in number, but high on people's mind. When, not if your decisions come to a stalemate, these relative priorities are what we can refer back to help come to a decision in the workshop. Finally, we get to the main crux, the agenda of one-way doors, the big discussion points that you pre-circulated ahead of the workshop. This then sets the context for the rest of the day. So, what are some of the key decisions? What is the operating model that is going to build and support this cluster? Who owns the cluster? Do you have a dedicated team to own, operate and upgrade it? Or do the workload teams have control over the cluster and when updates happen to it? In some organisations, the high-level responsibility for your cluster is well defined. In others, it is emerging. Either way, get this noted down. The teams responsible for aspects of the cluster may have the deciding say on how those aspects work. Having these owners decided and known early in the piece allows for easier decision-making. People changes can be harder than technology changes, so design and build your environment for the people that will be operating and using it. Changing the operating model after the fact may result in disagreement over previous decisions and not invented here syndrome, resulting in re-implementation or friction. Now, the first Kubernetes-specific decision. How many clusters do you want? 1, 2, or many? 1 is not often the answer, although if you are cost-conscious and just starting out on the cloud, or you do not have any production workloads yet, you may wish to start simple and add as you go. As soon as you have a production, non-production split, you start talking about 2 or more clusters. Kubernetes is a single-tenant orchestrator. When you upgrade the cluster, it'll affect all of the tenants in the cluster. If you are sharing the cluster between disparate workloads, you will need to design and configure the logical isolations you want between the workloads, be they namespaces, quotas, or role-based access controls. Think about the upgrade cadence of your applications. Can they all move fast if there are requirements in your next major version upgrade of Kubernetes? Can they all update at the same time? Do you need provable network isolation for your regulatory or security requirements? Do you want simple cost attribution, or are you okay with extracting cost metrics from your cluster using tools such as KubeCost? Talk through these requirements, along with the quotas and limits that are documented for both Kubernetes and AWS. Will you hit the maximum number of nodes in a cluster or maximum number of total pods in a cluster? How about in 2 years' time? The limits change over time, and the EKS limits may differ slightly from the general Kubernetes limits for a version. Having increased segregation for both increased security, reduced blast radius, and freedom on the timing of Kubernetes major version upgrades all lend weight to creating many clusters. Consider if your workload team want a say in when the workload cluster should be upgraded. Can you upgrade all the workloads at the same time? Choosing many clusters, though, will take more upfront effort for scripting your cluster settings and increases your operability burden. Different organisations will come out with different results here, and the choice here will flow into further decisions and implementation details down the path. Now the next big decision: storage. Containerized workloads excel when you design them to be stateless and your data stores externalized. Your upgrades, resiliency patterns, and scalability patterns are simplified. But not all workloads can be designed like this. Or perhaps your workloads are third-party vendor supplied. So the big question is, will you allow stateful services with persistent volumes? EKS allows for this with a set of supported container storage interfaces, or CSI for short, which you can choose to enable in your clusters. The AWS supported CSIs enable storage options including EBS, EFS, FSX for Lustre, or FSX for NetApp ONTAP. Allowing persistent volumes will increase your upfront work in building the cluster, bringing in backup requirements as well as operational burden in alerting and monitoring for disk usage. If you choose to use EBS storage, you further need to consider the availability zone resiliency angle and design your cluster and applications to ensure that you have nodes in the correct AZs in the event of failures. For details here, I suggest reading the Data Plane section of the EKS Best Practices Guide. Consider where RDS and other AWS managed database services will fit in your technology mix and whether this mitigates your need for persistent volumes, if only to save you upfront work. Starting without persistent volumes is a two-way door, but once you have enabled them and they are in use, you are committing to your organisation to support them ongoing. Do you need persistent storage for phase 1 of your project? Or can you delay it until phase 2, after simpler workloads are implemented? Now, moving on to Kubernetes networking. Kubernetes has a concept of a Container Network Interface, or CNI. This is a plugin into the Kubernetes cluster to define how Kubernetes interacts with the network. AWS only officially supports the Amazon VPC CNI plugin directly. Alternative CNI plugins are available and are documented in the EKS user guide, with links to the vendor's installation instructions for if you have specific requirements that mandate their use. The advantage of the Amazon VPC CNI is that it ties into the EC2 network interfaces to assign IP addresses using the native AWS networking. This should provide both a performance benefit over overlay networks, as well as allowing the use of security groups for securing pod communication to AWS resources outside of the cluster, for example, RDS databases. Whereas, an advantage of overlay networks is that the IP addresses of the pods are not tied to your VPC configuration. They are hidden within the Kubernetes environment. EKS Anywhere is currently defaulting to using Cilium for its CNI. If you go down this route of alternative CNIs, you should consider paid support from those vendors. Of note, when using the VPC CNI, you may still use the network policy provider from Calico in order to provide network policies across the cluster. This is a different configuration to using Calico's overlay network. Now, with your move to Kubernetes, you'll be using many more RFC 1918 private IPv4 addresses. Do you have ample IPv4 address space? When implementing Kubernetes, every node and every pod on each node has its own IP address space. This adds up fast. People want to conserve IPv4 addresses. Whilst there are options here, changing the subnet design of your network can be troublesome, or in some cases not possible after the cluster creation. So these considerations need to be done carefully. So, what are the options for opening up your IP address space? With the AWS VPC CNI, you can use custom networking to place the pods in a separate subnet to your nodes, routing the pod subnet through a NAT gateway if it needs to speak outside of your VPC. This allows you to reuse a pool of IPv4 addresses across clusters for pod networking. Or, if your applications, supporting toolsets, and all of the Kubernetes features and plugins used all work with IPv6, EKS supports IPv6 only networking for pods. This can open up your IP addresses fast. When a pod needs to talk outside the cluster to an IPv4 only address, the VPC CNI will direct the traffic via an IPv4 path, simplifying your networking requirements as you transition to IPv6. For deep details on IPv6 networking for EKS, see the launch blog for EKS IPv6 from January 2022. As IPv6 support emerges across further services and Kubernetes features, this becomes an attractive option for improved scalability. Work through the details with an AWS networking specialist before diving into IPv6 if you don't already have IPv6 implemented in your organisation. Next up, ingress controllers. Ingress controllers are a way for you to route traffic that starts from outside the cluster to services running inside the cluster. To get the best performance and scalability, we recommend that you use the AWS Load Balancer controller for ingress. This controller will natively use AWS network load balancers or application load balancers to direct traffic to your applications. If you have specific requirements which are unable to be handled by an NLB or ALB, or if you have vendor-supplied tooling providing a layer in front of your cluster that has native Kubernetes integration, you may wish to use alternative ingress controllers. Whilst you can have multiple controllers installed in your cluster, once you start deploying applications, changing your mind here will require you to update all of your deployments to the new type of ingress. It might be that you require the exact same notation between EKS Anywhere deployments and EKS deployments, and as such you want to use the Nginx ingress to have the same notations and reduce deviation in deployments between the two. Or perhaps you have custom mutual TLS authentication that you require. Or maybe you are integrating with third-party API gateways. Be aware that depending upon the alternative ingress controller's implementation, you may get an increase in node-to-node traffic if the traffic is unable to be routed completely ahead of hitting the cluster. If you are providing a choice to your applications, provide clear guidance and sensible defaults. Now, it is time for your security architect to come forward. Security is job zero, with many non-negotiable requirements that must be factored into your design. Which vendors are you using in your security landscape? Do you have a list of them that the team can reference? Ensure that the non-negotiable tools are documented up front and that all people understand the purpose and agree that they are required. What operating system will your nodes run on? Do you intend to use Fargate to avoid managing the operating system yourself? Or do you intend to use BottleRocket for a minimal, secure operating system designed for containers? Plan ahead for any differences in supported functionality between these offerings. Otherwise, consider your operating system hardening policies and ensure that you start with a hardened image, rather than attempting to harden the image after you have everything configured. It is much easier to start hardened rather than retesting all of your deployed workloads as you add in hardened configurations. By default, Kubernetes stores secrets in etcd as base64 encoded strings. EKS then encrypts these at rest with EBS encryption. We recommend you further enable AWS KMS envelope encryption of Kubernetes secrets. This should be done at cluster creation to ensure that all secrets are envelope encrypted in etcd, rather than just base64 encoded. If you do this after the fact, you may need to go through and audit the secrets in your environment and rotate them to force encryption of the changed value. Finally, do you have a list of preventative controls that need to be implemented? Getting these in early can help prevent accidental breaking afterwards. Open Policy Agent with Gatekeeper is a common open source way to lock down the cluster, with a number of sample controls in Gatekeeper's GitHub repo. Get some of the bigger constraints in early, be it preventing all privileged containers, or perhaps enforcing read-only root file systems. Whilst you can pre-audit your environment for impacts, implementing these changes after the fact requires coordination and care. Now, a big note for the teams to be aware of when designing how you bootstrap a new cluster. When an Amazon EKS cluster is created, the IAM entity, the user or role, that creates the cluster is added to the Kubernetes RBAC authentication table as the administrator. This becomes the break glass administrator for your cluster. Be both aware of which role will be used for the cluster creation and ensure it is a role that is adequately secured. Once your role-based access control is set up, you should not need to use the role again, except in a break glass scenario. Whilst not necessarily a one-way door, you can remove much friction early on by agreeing on and implementing your method for access into the cluster. Be aware of referencing the documentation that OpenID Connect, or OIDC, is used for both access into the cluster by users when using a single sign-on provider, and OIDC is also used for access for Kubernetes service accounts, and therefore pods, talking out to other AWS services. Here, the part we are to consider is talking into the cluster, where you can register your enterprise authentication system with Kubernetes. Will your people use their AWS account authentication to then access the cluster? Or will you use your enterprise authentication directly? Note that you can currently only associate one OIDC identity provider to your cluster. Please read through the considerations in the AWS EKS User Guide to work through your decisions here. Okay, now for orchestration. Changing the tooling used to orchestrate your cluster's creation and cluster settings after the fact can be complex. Choose your tooling based on how your organisation works and where you have existing skills. Your first choice. Are you planning to have a pull-based GitOps model or a more traditional push-based pipeline? I'm going to suggest that you don't start off aiming for manual deployments. If you're aiming for a pull-based GitOps model, you may choose tools designed specifically for this model, such as the CNCF project Flux, which is a default GitOps tool when creating an EKS Anywhere cluster. There are other tools that can be used in this space, including Argo CD, or perhaps do-it-yourself GitOps with your existing infrastructure as code tooling, such as Amazon CDK, or HashiCorp Terraform, paired with fully automated pipelines. Otherwise, you may wish to use a traditional gated pipeline with your favourite continuous integration tool, running your infrastructure as code with your existing change control processes and scheduled deployments. Your big decision here is the form of configuration that you are committing to source control, which will be based on the tools chosen. You do not want to be changing this configuration format or tool after the fact, as there is complexity and risk in translating between the various formats. I went through this decision process recently with the team at NAB. NAB is customer-centric. The engineering teams provide applications for their customers and their business that are secure, performant, resilient, reliable, and can adapt to their customers' expectations. The challenge for NAB is to do this with the vast scale, both in technology and people, and in a highly regulated industry. To do this, they have built out their very own NAB Engineering Foundations, or NEF, which has provided their technical teams the ability to remove the undifferentiated heavy lifting, so they can concentrate on the outcomes. The NEF team build tools and platforms that help standardise deployments with repeatable outcomes, which enable developers to focus on their code and customer-facing features and less on compliance, integration patterns and hosting. NAB managed EKS using Amazon EKS is one example where NAB continues to iterate. A centrally managed NAB EKS service at scale across all teams, providing a centrally managed platform with CD and CI. The outcome? Hundreds of development teams will be saved from reinventing the wheel, enabling them to concentrate on customers. In the words of Dennis Advani, the head of product management for NAB Engineering Foundation, NAB's new engineering foundations, supported by EKS, are helping prepare for the future of digital banking services. So, now that we've talked through all of this, what are your next steps? This here is the tip of the iceberg when scaling Kubernetes across a large number of enterprise workloads. Your one-way doors may include further decisions, so please speak to your AWS account team and have an AWS Solutions Architect help you on your decisions. The points talked about today are distilled down from some of the bigger decisions in the Amazon EKS Best Practices Guide, a continually evolving resource maintained by AWS to guide you on your implementation. Many of the points in the Best Practices Guide are two-way doors, and your implementation team will be able to go in and make quick decisions themselves. Kubernetes I/O also has a generic Best Practices Guide, which should be cross-referenced, including considerations for large clusters. And finally, to try out many of these concepts in a hands-on manner, the Amazon EKS Workshop site has walkthroughs and explanations for many scenarios, from beginner to advanced concepts. Once you have followed all the links from my previous slide, you may then want to dive into some free digital courses or test yourself on a certification. Feel free to follow me on Twitter or LinkedIn, and please complete the session survey. Thank you for watching.